你好，我叫王杰克，我拍我的化学课，我的老师有一点儿布鲁克林口音，对这个我对不起。我拍过班，主要集中对准备为标准化考试。这个意思是，这些词对化学课不太重要。选择了的话是不是多用了？但我认为他们是非常重要的。
And this is pKa of the indicator. So essentially what I'm trying to say here is the H ion of the acid solution, the H ion of what you were trying to titrate, controls this equilibrium of your indicator. So in the beginning, when you haven't added any OH, so let's say you're titrating an acid, and here in your burette, you have base. Okay? So in the beginning, the solution is heavily acidic because that's what you got. You got acid. So in the beginning, the H ions from your acid are going to push this equilibrium to the left, the Chatelier's principle. So you're going to be mostly in the acid form. And this is called the acid form. This is the base form. And two different colors, as you see in this first chart I just gave you. There's an acid side color and a basic side color. And as you go through it from acidic to basic, you go through like a gradation of color for these indicators. So in the beginning, when your solution is very acidic, a lot of H's coming from your flask pushes equilibrium this way, and you have mostly this color. As you titrate, you're adding OHs, and you're adding more OHs and more OHs, and eventually there's like no more O. And as you add OHs from your burette, the H ion concentration goes down. That's the stress, and this equilibrium, the indicator equilibrium, will start to shift to the right to make up for that. So what's driving this, what's controlling this equilibrium is the pH of the solution, is the H ions in the solution. So if you have a lot of H ions, it's going to drive it to the left, acid color. When the H ions in the solution go down, then this equilibrium, although there's not much of it, but this equilibrium will shift to the right and start to give you that color. So it turns out, so the pH of the solution controls the position of equilibrium of your indicator. So this indicator can go bouncing back and forth, and what it does is not dependent upon the H coming from the indicator. It's like subservient. What's controlling the position of equilibrium in this indicator's equilibrium is the pH of the solution. So the pH of the solution is going to drive this equilibrium of the indicator either far to the left or start to push it to the right. Now, what happens is when the ratio of this guy to this guy is around 10 to 1, as I mentioned the other day. That's about the minimum ratio that the human eye needs to discern one color over another. So, what's the minimum pH of the solution? Remember, the pH of the solution controls the position of this equilibrium. Controls whether it lies far to the left or whether it lies far to the right. This equilibrium is dependent upon the pH of the solution, which is what you are titrating in the whole thing. So this ratio is 10 to 1. The log of 10 to 1, the log of 10 is 1. So pH to see this guy will be the pKa of the indicator plus 1. And when this indicator as the pH changes and the ratio becomes 1 to 10 in favor of that guy, there's when you're in very acid solution. When you're in acid solution, this equilibrium of the indicator shifts to the left, so you mostly have this. You have that color, because you have this guy predominating at least 1 to 10. 1 to 100 is even better, but at least 1 to 10 differential, you perceive this guy's color. So what pH is needed for that? Well, pH will equal to the pKa minus 1. Because the log of 1 over 10, in this ratio, the log of 1 over 10 is minus 1. log of 1 over 10 is 1/10, or 10 to the minus 1, the log of minus 1 is minus 1. So what you need is to see, from going from this acid color to this basic color, is essentially a pH change of 2 units around the pKa of the indicator.
What would you use minus, what would you use plus?
Well, no, we're not using either or. We're just saying a delta pH of 2 units is necessary in the solution. Remember, the solution is driving this the solution pH is in control of this equilibrium.
Why 2? Why not just 1?
Well, because you want to go from one color to the other color. So
Yeah.
you need 10 to 1 excess of this, and you see this guy's color. And a 10 to 1 in this guy, you see this guy's color. So when it turns out, when the pH changes at least 2 units, so that's the minimum change you need. So if the pH changes color, I'm sorry, if the pH of the solution changes by 2 units at a minimum, you as a human being can perceive a color change. But it's got to change 2 units around the pKa of the indicator. So let's just look at that first page that I just gave you. Indicators are hard. It's a hard concept. And sometimes I have to sort of like speak slowly and think about exactly what I'm going to say, because I don't want to. So here are a lot of indicators. And look at the top header, pH scale, on this first chart I gave you. So we have indicators, for example, the bottom one, methyl violet. The pKa of methyl violet is around 1. The pKa of that indicator, methyl violet, is around 1. So therefore, what pH range is that useful for? pKa plus 1 and pKa minus 1. In other words, from 0 to 2, if you wanted to see what's happening in that pH range of 0 to 2, methyl violet would be the indicator used. Because on the acid side, it's yellow. On the very acid side, it's yellow. But on the basic side, even though it's still acid, but on the basic side, it is violet. So that indicator changes color way down low around a pH of 1. Okay? Now there's another one, thymol blue. And there's many of these, I'm not going to go through each one. So they all have the different pKa. It's really the midpoint. Look at the pH scale, and right in the middle of that color change, or in the middle of that bar, the horizontal bar that you see going across, that's the pKa of the indicator. So pKa minus 1, or minus 2 or minus 3, it's definitely on the acid side. But the minimum change you need is that, let's look at phenol red, at the fourth from the top, phenol red.
Isn't that the most reliable?
Well, that's not a question of reliable. It's what you are doing. You know, what's the, okay. So let me show you, let me give you another one. Maybe, what's that? That's right. So here is another one. This is all from the Petrucci book that we used last year. So these are out of that book. One advantage of a textbook is it gives you a lot of information. So I got 4 different curves to show you. So here is the pH titration, or the titration